We're going to do some basic pre-processing here for some data that I found. And this video is just going to be very basic. It's going to be using pandas, and actually I think that's it, just pandas library in Python to pre-process some data. And the data that we're going to pre-process is this one, crime data from 2020 to present. That's the URL. And what does it look like? If we go to the landing page here, once it loads, look at what it looks like, and it's got a bunch of columns. Now, the reason I'm doing this is because I'm working on a project to cluster various data and use various clustering techniques, such as k-means I already used, and I'm gonna try DB scan as well. That's just, another point there, but that's the reason that I want to pre-process this data. So I'm just going to try to take a bunch of columns that I find useful, and I mean, it's kind of hard to throw away. Oh, you can, yeah. So you can see what these titles are. I don't really know what a lot of them mean, and honestly, on the webpage I couldn't find documentation about the data, so I don't know. I think I followed some of these links and I couldn't find any documentation. But there's a solution, and that is ChatGPT. And I'll show you how to use this to find what they mean. You'll see what I mean. So, alright. So this is a new Jupyter notebook that I've created. I'm just going to call it Crime. And we're going to import pandas. So this library here is used for, well, it's used pretty prominently in machine learning and then data analysis, because it can organize data very well, and you can work with that data very well. So I won't go too deep into pandas here, but we'll just look at a simple example. It's just going to be pre-processing without any other techniques. Maybe you've heard of encoding techniques, or you've heard of standardization, normalization, where you scale the data, which is a form of pre-processing, but this is just working with the pandas library just to change the columns around, maybe add new columns that are useful, work with DateTime objects. So I've saved this on my desktop, and I've also saved the downloaded data on my desktop. You can download it just here. And I just downloaded the CSV, comma separated values file. So pandas can import a CSV. You can also, well, really it's a read. So the function is called read CSV, or there's read Excel as well if you have an Excel file. Usually we import pandas as PD. Read CSV, that's the function. And you can store that in a data frame. I'm going to store it in a raw data frame. Well, I'm just going to call it df raw. Now, a data frame, if you haven't seen one before, you'll see what it does. It's very beautifully designed. So I'm going to read the CSV. Now, you just provide the path here, but since mine is in the same directory, I can just type in the name, because it's a relative path. So you don't have to, if it's in the same directory, you don't have to go all the way to the starting folder. Right, so this is probably going to take maybe a few seconds, maybe a bit more. So I realized that the file is called something else. It's called like this, crime data.csv. Trying to do this based on memory rather than looking at the notes. I think that's a better way to do this, because I can talk through what I'm doing and I can make mistakes and explain how to overcome those mistakes. Right. So, well, we've got the data frame. If we open it up, so this is what a data frame looks like if you haven't seen one before. It's basically the same data from here, organized very neatly. So it's got the same headers and tables and everything, headers and rows. So each row is an entry, and this data just represents crime data. So, I mean, if you couldn't tell from the title, it's just crime data. It tells you the date that it happened, the date that was reported, the time, area, part 1-2. I'll show you how I found out what that meant soon. And then various codes, gender and what's this? Descent of the victim. Anyways, let's take a look at the columns. So if we type in dot columns in the data frame, we come up with an object. It's not a list, is it? If we look at the type of this, it should tell us what type it is. Oh, it's just an index. So it's what it tells you right there. So that's something that's part of pandas. But anyways, so this is all the columns that are part of the data frame. It's the same columns as here. And we just need to take a look at which ones we want. So which ones would be useful. So I'm going to use it for a clustering. If you know what that means, it's basically just grouping data together that makes sense to group it together. So you have, let's say you have a 2D plot of 2 variables. Here we have many variables, or many features. If you have a 2D one, it's easier to visualize. And then you have a graph of those points. Then you can group together various ones that are close together. And it's a same theoretical idea in multiple dimensions, but you can't really visualize it then. But yeah, so we're grouping together data that makes sense, and then you can work with that data better. You can see if you have a crime that happens somewhere, and then a crime that happens in another place, you can see how they're connected, or if they're connected at all. Similar variables or similar features were the same maybe, or they were close by. Maybe they occurred in the same place. Right, so what are we going to do next? Well, we're going to see which ones I could use for this project. So if we take a look at the data frame and we put square brackets here and we type in the name of the feature, it tells us just that column. And we can do multiple columns like this I think we can do it like this. So if we do then date occurred, I don't think that'll work. We need to put it in double brackets. There you go. So if we put multiple features, then we can view multiple features like that. Otherwise, you can put a dot notation, I believe, as well, like that. Yep, so that's the same as viewing it in square brackets that we did from before. But anyways, this feature, I don't really know what it is. But if we put it in ChatGPT, so go to ChatGPT and type in, what does some kind of number, district number, I'm not sure, mean in the context of crime data. There you go. Look at this, and it will tell us, we'll scale the web and tell us what it probably means. Is that the right name? Yeah, Dr. No. That's a great movie. It's a James Bond movie, it's the first one. Very, very good. Document report number. Alright, well, it's a number, and obviously it's not going to be something that we're going to cluster. Now, it can be used to refer to each of the points or each of the crimes that happen. So we could, I don't know if I'll need this, but it might be useful to just put it in a separate data frame. So we could just say district number as a reference, and then we could just store that column in there. And that way then you can just refer, because the indices will be the same. So like over here we have the column of indices, 0, 1, 2, 3, 4, all the way up to how many rows there are, how many entries there are. So we can refer to different points that way. So we can see this one that entry 3 corresponds to this number. And that might be useful as a way to refer to individual crimes later on. I didn't do this in the previous code when I was just playing around with it, but I might as well just include it here. But we don't need this in the actual clustering data frame because it's not going to be used in clustering. So I'm going to create a data frame, a subset of this huge data frame with huge numbers of features, and that's going to be used for the clustering technique that I'm going to use. Now, date reported and date occurred. These ones will be useful, but I don't want to just get these columns here. I want to create another column, another feature, which I will put into my clustering, which is going to be the days after the crime occurred that it was reported. Right? So that way, I mean, if we look at these columns here, entry 0, well, that was reported on the same day. Entry 1 here, this was reported 1 day afterwards. So it's in the format month, day, year. So 1 day afterwards, then following that 7 days afterwards, and then 2 months afterwards. I want to create another column that calculates that, and we'll show how to work with that. Let's just write it here for now. Create column for essentially date reported minus date occurred. That's the formula for it. It's pretty straightforward. But because they're DateTime objects, which is an object that represents a time or a date, so they have a specific way of working with them. Because of that, there's a little bit more that goes into it. But since this is like the more complicated example, we'll leave that for later. And then time occurred. I'll take time occurred. So time occurred, we could use that. Let's take a look at just what that looks like. Yeah, we could use time occurred. Area and area name, right? So if we take a look at what these look like, I mean those are pretty straightforward, those names. We have the area corresponding to a certain area name. So 1 corresponds to central, 1 corresponds to central over here, so you can see that's the same. Southwest corresponds to 3. Now we could use area, which is already in this sort of format, but I'm going to be encoding it differently anyways, because encoding means converting categorical variables into something that can be fed into a machine learning algorithm or some clustering algorithm, because you can't use categorical variables. Now they've already encoded it a certain way here, and that's just representing an area by a number. But the thing is, a lot of algorithms take the order. So if you have 1 versus 2, they see some sort of relationship between them where 2 is greater than 1. So in this case, they would see that southwest is greater than central. But that doesn't make any sense. It's just an area location. So essentially, that's just a separate video really. But so if that didn't make sense, it doesn't really matter. But the point is that I'm going to use area name and I'm going to encode that in a different way, because this way I'm not happy with the way that I've encoded this, which is converting categorical variables, which is the area name, these are categorical, into an integer. So I'm going to take area name and not area. Area name. What do we have? Report. I think it means reported district number or something, but let's take a look at what this is. So it's district number. Well, let's take a look at how many unique values there are. So if we type in .unique, no, that's not the one. Maybe it's just like this. No, it's not. Ah, I know what I've done. So I've created double this here, that's why. Or maybe it will. There you go. So it's because I had the double square brackets there. So these are all the unique values in that row or in that column. So I just want to see how many there are, because if there's one for every single row, so there's not. So there's 1 to 09, and I didn't show this before, but if we look at the info of the data frame, it tells us how many rows there are, or entries, 98,000 or 986,000 entries. Wow. So what does this represent? Well, you can find out IPT, maybe we can just type it in there. There you go. So it learns from what I said before. Report district number is a code to designate a geographical area or district in which it was reported. I don't think I'm going to use that one, because I've already got the area where it occurred. I'm not going to worry about where it was reported, so we can just skip that one. Now part 1-2, I'll show you what it means. Now if you didn't type in this before, you would have to write then what does part 1-2 mean in the context of crime data, but here it recognizes that I've typed it in before. So essentially what it means is it's classifying offenses based on their severity. So part 1 offenses are the most serious crimes, and then part 2 offenses are less serious. You can tell by what these are that they're more serious than something like trespass. Criminal homicide, yeah, that's probably pretty serious. So that's what part 1-2 means. So we're going to keep that one because that's a useful indicator, and it's just two different values, right? Like if we take a look at that column, look at the unique values, we see there's only two values. So we're going to keep that one, part 1-2. Now, what is CRM code? I believe it means crime code, if I remember right. But let's take a look at what the columns are. Well, it's just numbers, and you can see that some of the numbers repeat as well. If we look at the unique values, there is a low amount of unique values compared to how many entries there are in the data frame. And type it in ChatGPT. Crime code, yeah, it's explaining certain crimes. And then crime code description, that's what that means. And if we take a look at that, yeah, you can see that they're descriptions. Now, really, if this was without error, there should be the same amount of unique values. And that's what this is doing. So it's finding unique values and then taking the length, which is how many there are. So we can compare these two. And they're the same. But let's say that they had wrong spelling, because it's probably pretty likely that some data, it's easier to make a mistake on the spelling of a whole sentence than it is or like a specific format or a whole sentence than it is to make a mistake on just a code, which is a integer value. So in that case, I'd take the crime code and I wouldn't take the crime code description, because then it's more likely that there's no mistake. So I'm just going to take the crime code, and that'll be another categorical variable, and it's an integer, right? But I'm not going to take the integer as it is, because I don't think that there is any order in the codes. And the reason being is that when I looked deeper into the data frame, I looked at the severity of certain crimes, and there was no order with it. Like, the higher you get with the crime code, I couldn't see any. It didn't represent any more severe or less severe crimes. So I don't think there's any order with it. Now, an interesting thing that I might do separate to this, because this is going to take a lot longer, that I just thought of now, is that you could take a look at each individual crime and rate them yourself with how severe they are, and then represent it that way in the data frame. So that would take a lot longer, than you'd have to subjectively rate crimes based on how severe they are. And, well, I mean, of course, that's subjective, right? And there's ethical issues with that involved. But I mean, like, I think that's the way that they did it was better. We have part 1-2. So there's just two headings. Is it severe or is it not severe? Rather than like comparing two different crimes that where in the context of two different situations they could be different, like severe. One could be more severe than the other, or the other way around, you know? So we'll take the crime code. Now, codies, whatever that means, I forgot what this meant. And then if you put it into ChatGPT, oh yeah, so this is a code related to how the crime was carried out. If I look at what it is, yeah, there's a lot of NaN values as well, null values, so there's no value put into that entry. But it's just a code representing how the crimes were carried out. For my sake, because I'm more interested in just the clustering techniques and learning through those, this one's going to be complicated to represent with that way. I don't even know if you can really represent it that way, because there's so many different values. Like, if we take a look at the length, the number of unique values, there's a lot of them. Yeah. So, because obviously there's many different like ways that crimes could be carried out. So we're not going to take that. We're not going to take the age of the victim or the sex of the victim, and reason being is because if I remember right, if we look at the info of the data frame, it tells us how many non-null values there are. Oh no, there is one for age for everyone. So you can see at 986,873 entries total. Where it's less than that, there's null values. And that's not really a big deal, because you can just remove the rows. But I'm not going to take the sex of the victim anyways, because with my project, I'm more interested in the information related to the perpetrator. So I'm not going to take the age, sex, descent, premise. I believe that's where it happened. Premise is like a more specific location. Premise code categorizes a location. Yeah, and I remember you can kind of tell what that means based on the description of the premise, which is premise description. Yeah, so it tells you bus stop, restaurant, sidewalk. That'll depend on the location as well. like they'll be related in some way. I'm not going to take those ones. I'm not going to take weapon used. There's a lot less values anyways, and that just introduces more complexity to something that's already going to be more very complex. Weapon description, status. So that's status is if we take a look at the description of the status, that tells you what's happening if someone's arrested or if it's continuing. Then different various crime codes, and then location, another location. Don't know why there's so many locations. That's not going to work. Another location. That's right. Latitude and longitude. Oh, that could be another interesting thing. If you just plot the latitude and longitude, maybe we'll do that at the end if the video doesn't go on for too long. We'll just plot the latitude and longitude, and you can see exactly where the crimes happen in a map of them. I believe this is just in New York, right? Oh, Los Angeles, LAPD. City of Los Angeles. I don't know if it's just representative of Los Angeles. I don't live in America. I don't know the geography. Anyways. Alright, well, we've created some things to work with here, and that's just what we're going to take from there. So, firstly, we need to... Well, the way that we're going to do this is we're going to create a new data frame here, and we're just going to take the columns that matter. So we have the time occurring, the name of the area, this one, and crime code. There. And get rid of this. And the info. Alright. Excuse me. So if we just run that code there, we'll have a new data frame where, no, that's not right. So we need to actually take that from the data frame raw. So it's just a subset of that. And then we have 4 columns there. I feel like I had more columns before, but that doesn't matter. Let's just work with this. I don't want to look at the notes because that just takes less. That just makes it less genuine, right? Less authenticity. And this way I can talk through what I'm doing better. Right, so, well, we're going to take the date reported minus the date occurred, but essentially we've just taken all of these here, and now we just need to make a function that creates a new column where it's the days after that it gets reported. So we can go insert. So this function inserts a column at a specific index. So if we insert it at 1, it will insert it between time occurred and area name. If we insert it at -1, then it will insert it at the end. I don't know if we can actually write -1, but we can just count how many indices there are. So 0, 1, 2, 3. So 4, essentially. 4 is a non-existent index, so we insert it at the end. So this will insert at the end. But if we insert, so let's just do that, just so I know that what I'm talking is correct. If we insert a new column and we call that column days until reported, and then we put in a specific function there. Now, what is that function? Well, this is a DateTime object. If we take a look at that specific, or those columns there, or we can just write df_raw.info. So these are objects here. And let's see if I remember. I might actually have to look at the notes to remember this. What do we have here? All right, well, first we have to convert them to date time. So it looks like the So what I'm looking at is here. What I'm looking at is there, and what it shows is that first we need to convert it to DateTime objects, which we can do with the function pd.toDateTime, and then specify the format of them also, because right now they're in objects, but they're not in DateTime objects. And this is the format. So I'll show you where I found the format codes, which is these little values here, and I'll show you how to do that essentially. So we convert the column of the data frame to DateTime, and then we set it as that column. And then essentially the way we just do it is just minus the date that it occurred from the date that it was reported. And then we insert it as a new column there. All right. So I cheated a little bit. I'll look at my notes, but that's fine. Okay. So if I go to ChatGPT, this is kind of how I found that out. So so if I tell you, really I found that out by typing in how to find the days between two DateTime objects. Let's actually write that down. How to find the days between two DateTime objects. There you go. So you can subtract one DateTime object from another. That's what it shows to find the number of days. The result will be a time delta object. So that's the object that we're going to create essentially. And the example that's given that ChatGPT gave is creating two DateTime objects and then calculating the difference between the two dates by subtracting one from the other. Now, if we do that just as it showed, and I realized that in my notes I created a deep copy, which will be useful so that we don't have to, what was the code again? Copy, right? df_raw.copy. So what this does is it creates a copy of the original raw data frame that we can work with, and the reason being is that if we want to reset, or if we want to have the raw data frame to work with again, without this we would have to run this cell from before, this first cell again, to read in the original data. But problem is if it takes a long time. If it takes a really long time, then that's just excessive. So instead we can just create a deep copy, and then if we need the original data frame, we can just refer back to this df raw. So we're just going to work with df here. So that's really what I should have done before, but that's there. Let's put that over there. All right, so if we just do a time, so if we have what is it, date reported minus date occurred. So now we're just working with df here, and I'm actually probably should run it again because when I was working with it before, I just worked with the raw file. So just in case, I'll run it again, but I'll continue writing this as we go. So if we just subtract it like this, luckily the data reads pretty quickly. Now we get an error because it's spelled wrong, but do we still get, yeah, we still get an error. What's the name of the column? Oh yeah, right. So the reason that we got an error is because the df that we're using was already the one that had the date reported and date occurred removed. So really we should put it into here, there, and then we can work with the data frame, right? And now the new data frame column will have just the ones that we care about, which is date reported and date occurred still. But if we subtract this, we'll still get an error. even though we spelt it right now. And it's saying it's an unsupported operand type for string minus string. So essentially we're subtracting a string from a string, which is telling us that the columns of date reported and date occurred are not DateTime objects. They're strings. Or they're, well, I don't know if they're strings, but they're not DateTime objects, certainly. Maybe we can actually find out what they are. Type. Oh, it's the data frame. Can we do it like this to find the type? Series. So it's not telling us what the date reported. What it's telling us here is an object, right? So essentially it's not a DateTime object. I feel like if it was a DateTime object, it would say that. So if we convert it to a DateTime object by writing pd dot, what was it, to DateTime, I think? Yeah, to DateTime. pd dot to DateTime. Yep. And then we need to specify the format of it, which is basically the way that it's laid out. So what do these numbers represent? If you go to ChatGPT and type in DateTime format or something along the lines of that, it will tell us the code. There you go. So it tells us the format codes and what it represents. So percentage capital Y is a year. Percentage 2-digit year is percentage lowercase y. So it depends on how the year is laid out. But essentially we have, this one's the month. And I know that this one's the month because there's values of 24 here and there's not 24 months in a year. So it goes month, day, year. So we can write that just here. So we put it in marks and we write percentage, what was month? Month was, 2-digit month was lowercase m. And then there's a slash. And then 2-digit day is lowercase d. There's a slash. And then the 4-digit year was uppercase y, like that. There's a space. And then we have hour, minute, second, which is over here. We have hour. Well, it specifies the AM or PM, so that'll be a 2-hour format. So it's a percentage I, but it doesn't matter because all these values have just 12 as the same, it looks like. Percentage I, like that. And then we have the minute, which is percentage M, and then percentage S. So capitals, like that. And then AM or PM. So percentage P, like that. And if we run this code, yeah, there you go. So D type is now DateTime. And you can see that the values changed because the representation, the default standard representation of DateTime is just, it looks like year, month, day, but we can change it around. But essentially, so we've converted this one to DateTime. Now we just need to convert the other one, which is date occurred, to DateTime. And it's in the same format, so we can just do it like that. But we need to, of course, store that in the same column. So this one's date reported, and this one we store in the date occurred because we're storing in the same column. We can copy these over here. Yes. Right, so now that we've done that, we can subtract one from the other. So I'm kind of going all over the place here, but I'll do this in a separate column. So that's all the error from before. But now if we first convert it to like this, and then run it, Now it gives us a warning. The value is trying to be set on a copy of a slice from data frame. I'm going to take a look at how I did it before. I don't know if I fixed this before. I don't think the warning ran before, but P.2 date time. I mean, the warning isn't so much of a big deal. It's just saying that I guess it's an inefficient way to set something. I'm sure there's I mean, we can put it into ChatGPT just real quick and see if. So it looks like it's because of the this one, the first 2 lines. But let's just put it into ChatGPT and see if it comes up with something. I think we can fix it by just creating a copy. So maybe if we create a copy. So it's saying that it's unsure whether or not. Yeah, so it arises from the ambiguity of whether you are modifying the original data or creating a copy of it. So it's just giving a warning, so it's not really a big deal. I mean, I'm not really concerned with modifying the original data here as the data frame, but I'm going to see if this fixes it. Oh, it doesn't. That's right, whatever. It's not the point of this video anyways. Anyways, we get the number of days. So if you remember from the first one, it was 0 days. The second index was 1, in fact, and then it was 7 days. Now I said that the third one was like a month or something, or 2 months or something. So let's take a look at what it was. Right. So it was actually 3 years and 2 months. So the years are different. I assume that the years weren't different. That's why the difference is so much bigger there. So this one, yeah, it's 7 days, 1 week. This one is 0, this one is 1. Yeah, so it checks out. But I mean, the code is there, right? So you can see with the code that we're just subtracting one from the other. But we need to create a new column, essentially, and you can do that over here. And all we need to do is just copy this into this code here from before that we inserted here, where we insert in the 4th column a days until reported column, which is just the date that it occurred from the date that it was reported subtracted. That's just the difference. If we run this, then we get that warning from before, but if we take a look at the data frame, oh, now it's different obviously because we included a couple more columns. So before we didn't have these columns, and that's why I put it at index 4, thinking that it was going to go to the end. But I think if we just put -1, then it might be able to go to the end. No, -1 doesn't work. Let's just put it at the beginning. Let's just put it at 0. There you go. Clear cell output. This one. Clear cell output. There we go. Now if we take a look at it, we have days until reported at the beginning, and then we have all those other values. Now I don't want date reported or date occurred because I'm not going to use those. I'm just going to use the days until reported. So we can just remove those ones. And we can do that with, I believe we can do that with pop function or remove. Let's ask ChatGPT. Pandas remove. That's not going to come up. Oh yeah, it does. How does it know exactly what I want to do? Oh, drop. Yeah, drop. I remember this. Right. So if we drop those columns that we don't need, so first we specify the axis, which is the axis. Are we dropping the rows or are we dropping the columns? So we're dropping the columns, which is axis 1, rows is axis 0, and then we just specify the rows that we want to remove, which is date reported and then date occurred. At the end, if we write in place equals true, then it'll just modify the original data frame. If we didn't specify this here, then we would have to put df is equal to all that. But in place equals true just kind of looks a bit nicer. So if we run this, positional argument, right? Is that how I did it? Oh, right, so we actually need to, so positional argument follows keyword argument. It's a keyword argument, so we need to write columns is equal to that. I believe that'll work. Yeah, it does. All right. Yeah, so positional arguments are ones without the equals, so they don't have a name, or they could potentially have a name, but although of course they have a name when you're setting the function, but the keyword arguments, you have to write, I believe you have to write columns is equal to, or axis is equal, you don't have to write, you can just write 1, but that's something different that I need to look more into at some point. Anyways, did that not work? This is strange. I'm going to try to figure out what's happening here. Well, not found in axis. Well, let's take a look at if they are there. If we just comment out this here and then run df, well, we can see that they are in the axis. So I believe axis 1 was columns, yes, so it's even saying that axis is here. But the example that they gave here, which I didn't look at, is if we have multiple columns, you don't have to do the 2D array or 2D list. So what I mean by that is we just put one list of the columns, like that. Now if we look at this, yeah, there you go. All right, well, there's a couple more things that I just want to do. We've already created a column with what we want, or we've already created a data frame with what we want. So now all that needs to be done is just to convert some of the types of the variables. So if you remember what I was saying, part 1-2 is in reality a because, well, actually no, so part 1-2, I'm going to encode it in a certain way just now. So what I was saying is that I want to convert some of the integer values to objects, because I'm going to encode them anyway, so I don't want to get confused by seeing that they're already as integers, so thinking that I don't need to encode them in some way. For example, crime code, I'm not going to leave as they are. because if you remember, there's no there's no encoding done with them, right? They're just codes. So I'm going to encode them differently and convert them to other values. But for part 1-2, the only thing I'm going to do with that one is take that column and set it equal to that same column is equal to 2. And what that's going to do is just convert those values to 0 and 1. So if they're equal to 2, then this one's going to be 1, or that this one's going to be true, which is the same thing as 1. So this one's going to be set to, well, in this case, it should be just set to true. And this one, if part 1-2 is equal to 1, then it's not equal to 2, so it's false. And then that's just a 0 essentially. But if we run this like now, and then we take a look at the column, yeah, we get falses and trues, but we can just convert it to an integer like that. And then we get 0s and 1s. We just get 0s. Oh yeah, right, because we need to run it again. There you go. Nope. Ah, what am I doing? Yeah, 0s and 1s, there you go. So it needed to be run again because before, when I ran it for the second time, these values were true and false. They weren't 1 and 2. So it was then setting everything else equal to false. But essentially, if we run this code, then this code, then now they're converted to integers. So I'm just going to encode it like that. And we can just put that at the end here. So now the final columns that we have here, well, part 1-2, that is already encoded. I've just encoded it then. But crime code and, well, no, timer code, we might be able to just stay like that. But crime code, I'm going to convert to an object just to inform myself that I'm still going to be encoding this. And if you remember, crime code looked kind of like this. Like that. So we're just going to convert it to an object, and I think, and we'll just do an as type. Yeah, I was just thinking whether or not that's the right decision, but it is. So if we go crime code is equal to that same column dot as type object. If we run the whole thing again, of course we get these warnings which figure out what they mean later on. But then if we look at the info, we get crime code is now an object. There you go. So we have, well, I've pre-processed it how I want. This one's already encoded, part 1-2. Final thing that I want to do is that the days until reported is now a time delta object, but I want to convert it to a just an integer values because I want to work with them in the clustering, and clustering doesn't take time delta. I don't believe it shouldn't, anyways. So we can just convert it pretty simply. Back here where we created the time delta object, which is subtracting one data frame from another here. If we just write .dt.days, I believe this was the right code if I remember right, then if we look at this, There you go. Now they're integers. And what this does is it just takes the values from those time delta objects. So if we take a look at data frame, now instead of 0 days or 1 days or 7 days, we have just the values and they're integers now. Is there anything else that we need to do here? Area name, this is already not an integer, so it's pretty obvious that it's a categorical variable because they're words. So I'll encode that later on. And then time occurred, there is an order to this in some way, but maybe I can encode it in a different way. Maybe I'll save this for a separate video just because this video is already long enough to begin with. But let's see if I can actually figure out now. What I want to do is just encode it as 0 if it's in the morning, and then 1 if it's in the afternoon. And we just we can just do it like this. That should be actually easy enough. So df time occurred is equal to df time occurred is greater than or equal to 1200. So that'll be the cutoff. And if it's greater than or equal to 1200, then it's in the afternoon, which is a 1. Otherwise, it's a 0. So if we set this, and of course we get that error from before, and we take a look at the df, there you go. So we have trues or falses, and then we can just put as type int. Except I'm going to put this in another column because I still want the time occurred as just values that I'm going to use. But in case I want this value, I can set it as another column. So afternoon, morning, afternoon, like that. And if we write this in down here, and we run df. There you go. So we have another column for morning / afternoon. Well, kind of want to insert it at index 1. So I'm just going to use the insert function instead. Copy it into here. There we go. So with this, I'm just inserting it at index 1 under this header with this here. I don't know if this will work. No, it doesn't work because the as type needs to be within this here. Yeah, there you go. Now it works. There you go. Right. And I'm happy with that.